Okay, so this next unit I actually think is pretty cool. We're going to start off with some real-world application problems just for you to think through where you're going to see some of this geometry, or you might use some of this geometry later on. So I'll start with a really easy question. In this problem, my mom lives near the airport, and I live over here kind of on the other side of Eagleton Village near Rockwood. If the two of us were trying to meet up and pick like a fair location to meet up so that we both only had to drive the same distance, where would be the best place for us to meet up? And it's really easy when you're thinking about between 2 points, because you can just find right like the middle. We're just looking for what you all know as the midpoint. So maybe somewhere around MacArthur Road here would be a good place for us to meet up, because that looks like it's about halfway, assuming that there are roads that connect us there, right? So with two people, it's really, really easy. What gets a little more complicated is if you're trying to add additional people that you need to meet up. So if I wanted to add in here my in-laws, so my mother-in-law, she lives down here on the way to Greenback. So now the problem becomes a little bit more complicated, because it's not like I can just split the distance between two of us, because I now have a third person that I need to consider. So now I want to try to think about where would be the best place for us to meet up. So just an example, a really poor place for us to meet up would maybe be like out here near William Blunt. That doesn't make any sense, because like my mother-in-law might not be driving as far, but my mom would be driving further, and I would be driving like all the way across town. So we want to pick like a place, quote unquote, in the middle. So how do you find that place when there's three different parts? So I want you to pause the video and look at this map and see if you can pick where you think might be the best place for us to meet up. Okay, so it turns out the best place for us to meet is somewhere around here. And there's actually, so notice that I've drawn a triangle here. There is actually a specific way for us to calculate that this, in fact, is going to be about, and it will be exact if I was calculating it really well, equal distance from all three of those points. So let me show you how that works. All right, so the rule that we need to write down is that perpendicular bisectors, and you know what those are. Perpendicular means they're going to intersect to make 90-degree angles. Bisectors are lines that cut other segments in half or in two congruent parts, are going to intersect at the incenter. All right, so that's a vocab word we need to know. Creating a circumscribed, another vocab word, circle about the given triangle. Okay, so let's look at what I mean by that. So if I go ahead, let me go ahead and go back to that map. All right, so remember, we're trying to look for perpendicular bisectors. So if I look about, try to find the middle spot between my mother-in-law and my mom's house, and I'm just eyeballing it here. I'm going to say that's somewhere around this red dot. So there's the midpoint, but I also need to bisect that, or rather, draw a perpendicular line to that. Okay, so here's my point, and draw a perpendicular line. So I'm trying to create what looks kind of like a 90-degree angle. All right, so there's one of my perpendicular bisectors. Now I need to do that with each of these distances. So between me and my mom's house, it looks like this is the maybe the center point there. And if I go perpendicularly, so I'm trying to make this as best of a 90-degree angle as I can. All right, and then the last one would be between mine and my mother-in-law's. And this one is going to kind of fall into place. I'm looking for the midpoint. Oh, this is really hard to see with all these lines. Midpoint might be somewhere around there. And if I go perpendicularly. Now, notice that those are intersecting in that point that I gave you. Okay, so those are all perpendicular bisectors, right? We're creating this perpendicular. But what I really want you to see, and I feel like I should have done this in some better colors. Let me go back over. What I really want you to see, so I'm going to highlight in blue here, is these distances now are all going to be equal. And if you think about that, the only shape that we've ever talked about that has equal distance in all directions is a circle. So each of these is really like a radius. And now I'm writing in highlighter. Forgive me. And so if these are radii, then really we're creating this big circle. Hopefully it looks more like a circle. Out of the 3 points that we were given. So notice we have now put a triangle inside of a circle. So not only have we found the equal distant point, but we've put a triangle inside a circle. So let me show you that one more time. So what I want you to just wrap up again here is that perpendicular bisectors, so notice that's what I have drawn in blue here, these are perpendicular, end up intersecting in what we call the incenter. So the incenter is this point where they're intersecting, and you can label this on your notes however you need to, creating a circumscribed circle. So that is this circle. A circumscribed circle is one that is around a given shape. And that's how we can find a most central point between three specific locations. So let's look at one other follow-up question. So now we've just figured out how to put a triangle inside of a circle, or a circle around a triangle rather. So what I want to know is there a way to perfectly put a circle inside of a triangle? So draw yourself this triangle or a similar one and see if you can put a circle perfectly inside of that triangle. All right, now I have some kind of handy dandy little tools here on my iPad. I'm going to try to see if I can make a circle and get it to fit perfectly inside of this triangle. And so what I mean by that is I want it to touch all the sides of the triangle, but just perfectly. All right, and that looks pretty close. So let's see some things about that. So remember, a circle it's got a center. You all may have known just from previous classes that the distance from the center to the edge of a circle is called its radius. And if I go ahead and draw that, because I want this to be perfectly inside, if I draw each of the radii that get to that triangle, I don't know if you can notice anything, but first of all of these are obviously going to be congruent to one another because they're radii. And then also, compared to those sides, it's kind of difficult to see, but all of these end up being perpendicular. Now the question is, though, how do we come up with those perpendicular segments? Because these are clearly not bisectors. Like, this point is very much not in the middle of this given side. So how are we coming up with these lines? Well, there actually happens to be another piece of information, or another way to find that, and that is we're not bisecting the lines, but we are going to bisect the angles. So if I cut each of these angles in half, you're going to notice that the place where they intersect ends up being the center of this circle. And if these angles are being cut in half, we're going to call those, as you know, angle bisectors. All right, so let's go ahead and write that down. And what we're going to write down is that angle bisectors intersect at the incenter. So circumcenter is when the circle ends up being circumscribed around the triangle. This gives me an incenter because the circle is inside of the triangle. So in addition to having this picture drawn, the only other thing that I would do is just maybe make sure that you label that this is an incenter. That's what that point there is called in the middle. And then just make sure that you have written down angle bisectors, and or you've denoted that each of those segments is bisecting the angle. So the two things you need to know for class is how do we get a circle on the outside of a triangle? What segments do we need to draw? And how can we get a circle inside of a triangle? And if you know those things, you're going to be great for class tomorrow.